It's like the it's like the voice from beyond. You can't see me, but you can hear me. Now you see me. Oh, goodness. We're off to a great start this morning. We're here for SpaceX, going to be launching a Falcon 9 rocket. See if we can get the train back on the tracks here. They're going to launch a SiriusXM satellite today into... the rocket will launch it into geostationary transfer orbits, but eventually the satellite will go to geostationary Earth orbits, way out there, and provide some SiriusXM satellite radio to the people. Not sponsored. But that's where we're launching today. Just in case you're watching the replay or you're curious, is this live or is it not? It's December 13th, 2020, and it's about 12 o'clock in the afternoon, Eastern Standard Time, which is like 1700 UTC. That's what time it is right now. If that's the wrong time for you, you might be watching the replay, and I'll put timestamps in the description below so you can skip to the parts that you want to see. But if you're here with us live, thanks for joining me. We're gonna eliminate any further issues going forward, and we'll get to a good show today. We'll have some fun. So thanks everybody for jumping in and joining us. I see everybody's kind of been waiting around this morning. The launch window today is a 2-hour launch window that started at about 11:22. It's just under 2 hours. It's an hour and 59 minutes. So we're just gonna call it 2 hours today. But it started at 11:22. They ended up pushing it back about an hour and 8 minutes to 12:30. This is all Eastern Standard Time because they're launching on the East Coast, Cape Canaveral today. So they pushed it back a little bit. No word exactly why, but they did say that the weather conditions were a little more ideal for 12:30. So we're assuming that because of weather, they pushed it to 12:30 just because you'd have a better chance of launch. Now remember, the Falcon 9 has to, once they start loading propellant into the rockets, it almost becomes an instantaneous launch window. I mean, there's a little bit of wiggle room there. I mean, they could have potentially loaded at 11:22 and probably recycled if they had to hold the count. They probably could have recycled to hit the end of the launch window, but you're trying to find, you're looking at the weather, you're going, we have a 2-hour window. 11:22 is like, all right, it's okay. It was 60%, but 12:30 is 80%. So no sense in trying to go at 11:22. Let's go at 12:30. It's 80% go. So we're assuming that that's the reason for the slight bit of delay. But this is the second launch attempt that we've had for this flight. They tried previously 2 days ago, and they held the count at about 30 seconds for what I thought was upper level winds. Turns out wasn't upper level winds. It was ground support equipment. That'd be all the stuff on the ground that doesn't fly with the rocket. Something on the ground support equipment they needed to review and figure out what was going on. So that's what we're up to today. So why don't we jump into it, and I'll grab some of your questions here hopefully shortly. But before we do that, let's look at our flight plan for today. What do you say? Sounds like a good idea. All right, so this is courtesy of our friends at flightclub.io. Declan over at Flight Club is a genius and puts together these 3D simulations along with our telemetry that we will have again here today. It's going to look something like this. Simulated telemetry up there. That'll give us an idea of what the rocket is doing. It's not live telemetry. It's not directly from SpaceX. It's simulated, but it's mathed out. Declan does all the math, and he waves the magic wand, and he figures out all this stuff. It's awesome. So we'll get some simulated telemetry so you get a little bit of augmented view to SpaceX's feed. So, all right, let's go back to the 3D map here that we're actually going to look at today. So we're launching almost basically an equatorial launch here, almost going directly to the east here. You can see the orbit does change. We'll take a look at that in just a second, but we're launching from launch pad 40, which is a little bit further south to their big launch pad, which is 39A up here, which is where Crew Dragon launches from, Falcon Heavy, Space Shuttle, Apollo, all launch from these big launch pads up here at Kennedy Space Center. That's 39A and 39B. But down here, this is pad 40 for SpaceX. That's their secondary pad. So a little bit smaller, can't launch Falcon Heavy, can't launch Crew Dragon, can't launch the new Cargo Dragon anymore. But so these will be just satellite launches that go from Pad 40. But the good news is Pad 40 usually has awesome pad microphones. So usually love Launch Pad 40, Slick 40 for those launches. This one in between, this is United Launch Alliance, Slick 41. And all of this is on Cape Canaveral Space Force Station property. So this is Kennedy Space Center up here. And then this is actually Cape Canaveral Space Force Station property. So technically a whole different property there. How many times can I say property? Property, property, property. Okay. Anyway, so that's the 3D map here that we're looking at. They're going to go under powered flight, which is the red section here. They will have separation up here, quick separation. Second stage goes on into orbit. First stage is going to come back, do a landing burn, and land out at sea on the autonomous spaceport drone ship. Second stage is going to go, let's see, can we, yep, now we did it. Here we go. Can I navigate this? Oh, no. All right, well, second stage is going to go on, and it is going to do another burn, which is... Come on. I got this. Oh, maybe. Yeah. Here we go. All right. Oh, now the world is upside down. We're... Here we go. We got this. I got this. Maybe. Where's our second burn? It's over here somewhere. Oh, no. Oh, the humanity. It's not even shown on here. All right, well... Abort. This is going great. There's a second burn in there. Briefly. Just trust me. It's there. I can't show it to you, but it's going to happen. Let's go to our hazard map here just so you can see. We'll move on. You can see the hazards map put together by Raul over on Twitter. You can see our autonomous spaceport drone ship. That's the blue pin. And then the green pin is one fairing catching ship and one just general recovery ship. So our fairing today, half of it's been reused, half of it is brand new, and they're probably going to try to pluck both of them out of the water. Although they do have one fairing catching ship out there, so maybe they try to catch one. They definitely can't catch both because only one of them's out there. But whether they try to catch both or try to catch one or just let them both go in the water, we'll find out today when SpaceX goes live. No second stage re-entry area for this one here. So that second stage is likely going to go to a disposal orbit. And it's not coming back anywhere here. So second stage likely not coming back and burning up in the atmosphere. That'll likely get boosted to some sort of disposal orbit. That's the assumption that I am under. Now, weather today. We'll look at the weather map, but this is already outdated because this was the mission execution forecast for the entire launch window. It called for a 40% chance of violating launch conditions, which would mean 60% go. That's already been updated just like an hour ago. They're now down to 20% chance of violation and 80% go. So much better. The main concern today was cumulus cloud rules, which is generally something it's one of those things that can certainly improve on launch day. Because if we take a look at our weather map here and we look at satellite coverage, you get an idea of what the clouds are actually doing here. And it doesn't look like we've got what appears to be, always tough to tell on this map, but what appears to be some thin, wispy clouds here that are not really going to be much of an impact. You've got some thicker clouds out here, but the rocket will be up and over those well before it gets there, so it'll fly right over the top. So clouds was really the big concern for today, is right there. Winds were looking okay. Winds are always a big concern at Florida. 4 miles per hour ground level winds. Our upper level winds are always a little bit quicker. They're 130 miles per hour way up here in the Carolinas, but down here at the launch site, we're 78 miles per hour. We're heading this way, so it's actually getting lower in the upper level winds, but usually we're concerned about upper level winds almost directly over the pad here, like this general area here, and that's because the rocket obviously gets up and over those pretty quickly. When we're talking upper level winds, we're talking like 12 kilometers, 30 to 45,000 feet in altitude, so it's not very high. They can get up and over those pretty quickly. It's really right around that max Q call that is also where upper level winds are, is right in that general area, which is pretty short pretty shortly after launch. So not too much of a concern that I have for upper level winds today. And I guess the last, let's see, the radar is the last one we were going to look at. Nothing there. So we got no concerns for radar today. Now, what we're launching here for today, I had mentioned already, this is the SiriusXM-7 satellite. It's a satellite radio. You probably heard of SiriusXM. They're sending up a new satellite to provide their satellite radio. It's replacing SiriusXM-3, which I was having a difficult time trying to find it on our tracking map here, but I believe it's this one, but this is a very highly inclined orbit. But this is Sirius 3. I think is Sirius 3. I mean, it is Sirius 3, but whether it's the correct one, not 100% sure. This is at a very inclined geostationary. This is not even geostationary, so it can't be that one. I was trying to find it here on the map, and I don't know which one. I don't know which one it is. If anybody knows the designation of SXM-3 that it's replacing, send it to me in the comments, because I don't know which one it is. It should be out here in this red ring here. So it can't be the one that I selected. But the red ring there, that's your geostationary orbit. You have basically 3 main orbits around Earth. You've got what Starlink is in. This is our low Earth orbit here. You can see the Starlink grid. You've got your medium Earth orbit, which is mostly GPS satellites. That's what this Navstar constellation is, all GPS satellites in medium Earth orbits. And then geostationary orbit is that red ring that we see around here. Those are all the reds are all the satellites that are in geostationary orbit around our Earth. So that's what we got going for today, and hopefully we get an on-time launch. I did mention we will have some of the Flight Club data today. So we've got all of this stuff here that Declan develops, and he's got all of this factored into our gauges here. If you want to see it, you can go to flightclub.io. And these are all the telemetry graphs that he comes up with. There's a ton of information here, how much acceleration each of the stages is going to see, the aerodynamic pressure. You can see here's like our max Q right there, aerodynamic pressure. So you can see the pressure goes up and then it comes back down, because that's a method of, as the rocket increases in speed, it starts to impart a little more force on the vehicle, but also as it goes up, the pressure is going down. So you get this little cross where the pressure comes down, but the speed goes up, and eventually they cross right there, which is max Q. So you can see some of the aerodynamic pressure there in some of these graphs. And he's got a ton of stuff figured into here. You know, throttle control, angle of attack, the drag coefficients. He's got it all. So if you're looking for data, here it is. Declan at flightclub.io. He's a telemetry wizard. It's awesome. I love it. And we're going to have some of that, like I'd mentioned, in our gauges here that will be synced up with launch time and provide us some simulated telemetry. Usually SpaceX provides us just with stage 2 telemetry, and usually it's just stage 2, maybe altitude and velocity. So here we'll see stage 2's altitude, velocity, but also the acceleration, the throttle position. We'll also see the amount of fuel that's left, which is always kind of cool to see, because that first stage when it lands has like no fuel left. It's like just a drop of fuel left, and you can really see that they've just figured that out to be just right, because it's practically empty by the time it lands. So that's what we're talking about here today. That's kind of the idea. And SpaceX, looks like SpaceX has gone live. So I will pull that up here and we'll switch that over. We'll have to turn this up. Oh, I'll have to turn that down because they're playing music. But I'll switch it over here. And in the meantime, while we wait for them, I will grab some questions. So a couple people I saw asking what time is launch. Everybody always wants to know what time launch is. That's what this is for. Here's our timer. We're about 14 minutes away from launch. It may be a couple of seconds off because this is counting down to the exact launch time. There'll be a little bit of a delay by the time SpaceX sends the feed to me and then I send it to you. So we'll have to sync up these these two clocks. The clock here and the clock here will not be exactly there to the second. So I'll sync those up once SpaceX goes live so that they match. But we're about 14 minutes away from launch. You can also see the events that will go down as the rocket is being prepared for launch. Things like loading helium in, which is what they use to backfill and back pressure the tanks to keep them pressurized. Grid fins getting secured, T-tab systems getting ready, which will do the ignition process. So a bunch of stuff happening there. Let's see, Adam Farmer, thanks for the 2 super chats, 1 super sticker. All right, thanks, Adam. Appreciate that. Thanks for your support. Thanks for supporting the channel there. And looks like they're just about to get started. See if I see any other... Oh, there's Adam says, thank you for being so informative and making me feel connected to such an interesting event. Love your emotions as they mirror mine. Well, thanks. I'm glad you're having fun. I'm always having fun here, so I'm glad you guys are having fun with me. Let's see. All right, so SpaceX is live. Let's turn it up. We'll listen in. And I'll try not to talk too much, but I'll interject here and there.
From Cape Canaveral Space Force Station in Florida. My name is Kate Tice, and I'm a senior certification engineer here at SpaceX headquarters in Hawthorne, California. Welcome to our webcast coverage for the launch of SiriusXM's SXM-7 satellite. For those of you who tuned into our webcast earlier in the week, today marks our second attempt to launch the SXM-7 satellite. During our previous attempt, a hold was called due to a potential issue on the ground system side. The vehicle and payload remain healthy, and the Falcon 9 team has completed a thorough review, and we are go for today's launch. Now, if you're tuning in for the first time, you may know SiriusXM for its ad-free, curated music channels, or for its use of satellites to provide users with digital audio radio services. Today, to replace existing satellite services, SpaceX will launch the company's next-generation high-power broadcasting satellite, SXM-7. Following today's launch, the SXM-7 payload will join 5 other satellites in SiriusXM's active satellite fleet. After joining the fleet, there's an expectation that the payload will replace the XM-3 satellite to help ensure continuous and reliable delivery of SiriusXM's audio entertainment and data services to consumers in the United States. This effort will also help SiriusXM expand services to consumers in Canada and the Caribbean. Today's launch marks the 25th SpaceX mission of 2020 and the 7th flight for this particular booster, which is always exciting. Let's take a closer look at the vehicle for today's mission. There on your screen, you see our Falcon 9 rocket on the launch pad located in Cape Canaveral, cycling through its launch day processes in preparation for its 12:30 p.m. Eastern liftoff. Falcon 9 is a 2-stage liquid-fueled launch vehicle and stands about 229 feet or 70 meters tall, which is equivalent of about 12 giraffes stacked on top of each other. The bottom 2/3 of the vehicle is what we call the first stage. As I mentioned earlier, it will be taking flight for the 7th time today. The first stage is responsible for accelerating the vehicle all the way to the edge of space, after which it will separate from the second stage, carrying the SXM-7 payload. Once separation is complete, we'll attempt to recover the first stage on our drone ship, which you see right there on your screen. Just read the instructions. It's currently holding position in the Atlantic Ocean a couple hundred miles off the coast of Florida. If we stick the landing today, it will mark our 69th successful booster recovery. After the first and second stage separate, the second stage will ignite its single Merlin vacuum engine, or MVAC engine, to carry the SXM-7 satellite to a highly elliptical orbit. Separation from second stage will occur about 4,000 kilometers above Earth, and then the satellite will perform burns using its own onboard thruster to raise its position to enter a circular medium Earth orbit, or MEO, and reach an apogee of about 20,200 kilometers above Earth. If you look at the top of the Falcon 9 rocket there, you see a nose cone-shaped object. That's the payload fairing. Housed inside is the SXM-7 satellite. The fairing measures 17 feet, or about 5 meters in diameter, and 43 feet, or about 13 meters tall. The payload fairing protects the satellite from aerodynamic heating, loads, and contamination during ascent.
Did she just say it was going to medium Earth orbit? That's not what I was expecting.
The vacuum of space, the payload will no longer need that protection. We'll jettison the fairing halves so we don't have to carry around that extra weight, and the second stage will continue with the satellite to its targeted drop-off orbit. One fairing half used during today's mission is taking its first flight, while the other is being flown for the second time. That particular half previously supported the Anassist-2 mission back in July of this year. Due to upgrades on our recovery vessel, Ms. Chief, we'll instead retrieve one of the fairing halves with our recovery vessel, Go Searcher, and attempt to catch the other using our recovery vessel, Ms. Tree.
There you go. So one catch
The
attempt
large gray
today.
structure that you see there next to Falcon 9 is the Transporter Erector, or TE. The TE is used to roll out the Falcon 9 from the hangar to the launch pad and raise it to its vertical launch position. The TE also routes power, fluids, and communication to both the rocket and satellite. Our countdown continues to progress smoothly toward our 12:30 p.m. Eastern Time, so let's take a closer look at today's payload.
Might have some music here today.
Weighing in at almost 7,000 kilograms and over 100 feet long when its solar arrays are deployed, the 27-foot tall SXM-7, built on Maxar's 1300 class platform, is designed to provide service for more than 15 years. This satellite's unique design also features a large unfurlable S-band reflector to broadcast audio and data signals to users on the ground. By joining SiriusXM's already active fleet, the SXM-7 will deliver the highest power density of any commercial satellite on orbit. This new satellite will send more than 8,000 watts of content to the continental United States, Canada, Puerto Rico, and the Caribbean, which in turn provides users with a better signal quality and broader reach. Now, as the clock countdown continues for our on-time liftoff of 12:30 p.m. Eastern, let's take a moment to learn a little bit more about the SXM-7.
All right, so yep, they're going to play some music here now, so I'm going to turn it down because we don't have permission to play their music. So I'll just switch it over here. You'll be able to see what's happening on the screen. You'll see the satellites. If you want to actually see this actual video, you can certainly take a look at SpaceX's actual broadcast. They'll show you a little bit about the satellite itself, what's happening, you know, how they're broadcasting back to us here in our cars and our ground stations. I don't know. I have Sirius in my car, but I don't necessarily. I think there's ground stations too, right? It doesn't have to be in your car. Anyways, let's see. I'll take a couple questions here before they get back to it. Framrick says, one of our awesome moderators, once in geostationary orbit, SXM-7 satellite will unfurl a large S-band antenna-made reflector by L3 Harris to broadcast radio signal to receivers on moving vehicles. So I was expecting geostationary orbit, but I thought I heard her say that they were going to medium Earth orbit. I was very confused. Maybe they're parking in medium Earth orbit? I don't know. I'm going to have to listen to that back.
Our Falcon 9 team performed functional checkouts for the SXM-7 satellite. At T-minus 38 minutes, the team concluded their electronic go, no-go poll and gave the okay to proceed into propellant load and launch. To keep the propellant on both stages of the vehicle cooled as much as possible close to launch, the team at Cape Canaveral began that propellant load at T-minus 35 minutes. Since the second stage Merlin engine is very similar to the first stage engines, both first and second stage engines get to use the same propellant. Our fuel is a refined form of kerosene known as Rocket Propellant 1, or RP1, and our oxidizer is super chilled liquid oxygen, LOX. We chill the liquid oxygen to be as cold as we can get it, which allows us to load more LOX and makes it super dense with oxygen molecules. Both of these things give us better performance with the Merlin engines. This also helps us to avoid the need to continue topping LOX up. This also helps us to avoid needing to top off that liquid oxygen to make up for losses due to boiling. At this point in time, both the first and second stages are fully loaded with RP1. The first stage will be complete. Actually, it looks like we're approaching completion of load of LOX on first stage, and also at this time, liquid oxygen loading is continuing on second stage. The pre-valves between the first stage engines and the propellant tanks are open. At T-minus 7 minutes, we performed what is called engine chill. This is where we cool the turbo pumps in order to avoid thermal shocks when we start those turbo pumps up at T-minus 2 seconds in order to light the Merlin engines. At this point, we're also loading helium into storage vessels on the first and second stages. And you can see on your screen there, the cradle around the fairing has just moved a little bit, retracting and making way for launch. During flight, as I mentioned, we're loading helium into the first and second stages. During flight, we'll pass that cold helium through the heat exchangers on the Merlin engines. The heat of the gas generator exhaust turns that cold helium into hot helium, therefore expanding it. And that expanded helium gas is then used to fill the empty volume in the propellant tanks caused by the engine pumps pulling the propellant out of the stages. And it looks like we had a little bit of retraction there of the strong back. That is essentially just moving back a little bit, about 2 degrees into the pre-launch position, 2 degrees away from the rocket. At liftoff, hydraulics will move that TE into a position 45 degrees away from the rocket.
All right, we're coming up. We'll have a big vent in a minute and a half, but I saw Adam Farmer. Thanks again for the super chat. It says, why are my kids so disinterested in this? They love space, but don't care about rocket launches. What gives? I'm paying so they can hear you say it. Kids, this is cool stuff. This is awesome. They're going to launch this rocket. Not only launch it, they're going to land it standing up on a floating drone ship in the middle of the ocean. This is awesome engineering. Think of everything that goes into that. Come on, kids, get into it. Your pale Tory told you this is cool stuff.
At T-minus 2 minutes. 1 minute before liftoff, you'll hear the announcement that Falcon 9 is in startup. This announcement means that the rocket's own internal computers are now controlling the launch countdown on Falcon 9. Once the engines are confirmed to be at full power, the flight computer on the second stage will command the ground hold downs to release the rocket right at T0. The satellite team continues to monitor the status and health of the SXM-7 located inside the fairing on top of the second stage. All systems continue to be go on the satellite.
Looking good.
As of right now, as we just passed through the T-minus 2 minute mark, where everything appears to be on track for an on-time launch today. The range status is green, and of course we've been monitoring the weather. Today's primary concern was the cumulus cloud rule, but as we can see there from our shot of the pad on your screen, beautiful blue skies there in Florida. Conditions are looking favorable at both the launch site and recovery zone. If for some reason we have to call a hold on today's launch, we have a backup opportunity tomorrow with a liftoff time scheduled about the same time. But for now, all systems continue to be go for a liftoff at 12:30 p.m. Eastern.
This is the final big vent right here. You see a ton of venting happening from the transport erector there. They're draining all the lines in the transport erector, liquid oxygen lines, things like that. They're draining all that, getting prepared for launch. This is the last big vent, normal process, getting prepared for launch.
In startup.
All that smoke
in startup.
is just condensation from the
So there we heard the call out. F9 is in startup, meaning that the flight computers have taken control of the launch countdown for Falcon 9.
Here we go. Coming up on it now. Caesar
First and second
Anita's.
stages are beginning to pressurize for launch.
Do we get a go? I didn't hear a go. Come on.
LD is go for
The
launch.
white clouds that you see there is
LD
just...
is go for launch.
There we heard the final
Oh, I
call.
heard it
LD
twice.
is go for launch.
All right, here we go. Caesar, thanks for the super chat. Appreciate your support there.
Everything looking good for an on-time liftoff today. Let's listen in on the final seconds of the countdown.
All right, here we go. This is
15 seconds.
simulated telemetry. It's not live. It's a mathematical, educated
10,
guess here.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. And we have liftoff.
Stage 1 propulsion nominal.
Vehicle's pitching downrange.
We're now 30 seconds into flight, and Falcon 9 is preparing to pass through max Q, which will happen at T plus 1 minute and 12 seconds. For those of you that might be unfamiliar with this term, max Q is when the vehicle will experience the greatest amount of dynamic pressure. Call out there that everything is looking nominal for first stage. To prepare for max Q, we throttle the engines down and then back up about 20 seconds later. And this helps ensure that we keep those dynamic pressures below a certain level.
Falcon 9 is supersonic.
So there we heard the call out that the vehicle is now going faster than the speed of sound.
All right, we're off. Remember, there's a little bit of a mismatch between the
vehicle is experiencing maximum dynamic pressure.
So there we heard the call out that the vehicle is passing through max Q. Again, that's the moment in which the vehicle experiences the greatest amount of dynamic pressure, greatest amount that it'll see throughout flight. Now in just a few seconds, we'll hear the call out that MVAC chill has begun. Just like we did on the M1D engines for first stage, we open the pre-valves between the propellant tanks and the turbopumps, allow some of that super chilled liquid oxygen to cool down the turbopump hardware. There we go. So MVAC chill has begun. So that super chilled liquid oxygen is flowing through the turbopumps, allowing them to cool off prior to full flow of propellant. Everything is looking good with stage 1 trajectory. So coming up, we're going to have 3 events happening in quick succession. We're going to have main engine cutoff, followed by stage separation and SES1, or second engine start 1. Main engine cutoff coming up in 3 seconds.
And Miko.
There we go.
Stage separation confirmed.
All right, there on your screen we have confirmation of stage separation as well as MVAC ignition.
Good MVAC ignition.
Great view there of planet Earth rotating behind the first stage, which is on the left-hand side of your screen, and the second stage on the right-hand side. So on the left-hand side, we can see those grid fins beginning to deploy into the landing position. Those grid fins will be utilized to help steer Falcon 9 for a precise landing on our drone ship, which, like I mentioned earlier, is positioned a couple hundred miles.
Nominal trajectory.
Nominal trajectory there for Falcon 9. As I said, those grid fins will be utilized to help guide and steer the booster back to the drone ship.
Bearing separation confirmed.
So we got the first.
And confirmation that there you saw it on your screen, the 2 fairing halves have separated, exposing the SXM-7 satellite.
You can see it falling away from the second stage engine there. That's always cool to see.
If you look closely, you can actually see the fairing disappearing from view in the background there.
Now they are going to recover those.
Currently at
T
T plus 4 minutes and 3 seconds into flight. And we're performing the first of 2 planned MVAC burns. At stage separation, the first stage's velocity is about 2,200 meters per second, or 5,000 meters per hour. Pretty fast. Once the first and second stages separate, that first stage is actually still moving at such a high velocity that it continues to raise its altitude as it coasts for a couple of minutes prior to starting its downward return back to Earth.
Acquisition of signal, Bermuda.
Yep, so remember the first stage continues to climb.
The next major milestone that we'll be able to see will be that first stage entry burn. For the entry burn, we relight the center engine, which we call E9, and then partway through the transition back through the Earth's atmosphere, we relight 2 more Merlin M1D engines, E1 and E5, to give us a total of 3 M1Ds, helping to slow the vehicle down as it passes back into the Earth's atmosphere. We're expecting that entry burn to begin in about 1 minute.
So remember, the first stage continues to climb even after separation, eventually hits apogee and starts to come down. We'll do an entry burn.
Trajectory continues to look good there on second stage.
Then they'll do a
carrying
landing
the
burn. later.
SXM-7 satellite for SiriusXM.
So now you see
Vehicle is on a nominal trajectory.
you see that first stage altitude starting to come down. Speed picking up a little bit on the first stage. That's why they're going to have to do that entry burn to slow it down so it doesn't just burn up and break up
Gorgeous
into pieces.
views of first stage as it has now reoriented itself,
Coming in engine
coasting
first.
through apogee and now returning back down. As I mentioned, we will be performing 2 maneuvers for that landing. First, entry burn coming up in about 10 seconds, followed, of course, by the landing burn on the drone ship.
Watch how
Stage 1 FTS is saved.
Watch how fast those clouds come up. We should be getting an entry burn
First
any
stage
minute
is
here.
currently about 50 miles above the Earth's surface.
Grid fins going to work.
Entry burn has started.
There we go. There's entry burn. 3 engines used for
There we
entry
can
burn.
see that the entry burn has begun on the left-hand side of your screen for that first stage re-entry. Again, we start by igniting the center engine first and then reignite 2 more engines to give us a total of 3 engines, allowing us to slow the vehicle down as it re-enters the Earth's atmosphere.
Entry burn shutdown.
And shutdown of
There we
those
go.
3 engines for entry burn.
Now the grid fins go to work. We're probably going to
Trajectory
lose the
continues
camera
to look
feed.
nominal there for second stage on the right-hand side of your screen.
Usually right about here we start to lose the
I love
camera
that
feed
view
from
of
the
MVAC.
from the first stage booster. We might lose that and then hopefully pick it up with the drone ship camera.
Next up, we have a couple of major milestones
There it
happening
goes.
back to back. The start of the landing burn followed immediately by SECO 1, or second engine cutoff 1, on the second stage. SECO is where we shut down that MVAC engine to allow the second stage to coast for a little bit. This event preserves the fuel until we need it for the final burn to take us to our targeted orbit for the SXM-7 satellite. And then about 25 seconds after SECO 1, we'll hopefully have a live view of the first stage touching down
Stage 2 is in terminal guidance.
on our drone ship. Just read the instructions. So we're expecting the landing burn to begin in about 10 seconds and SECO to begin in about 15 seconds.
Stage 2 FTS is saved.
FTS safe. That's flight termination. We should be under landing burn here. We're going to get a feed.
Everything continued to looking nominal. And there we heard the call out
There's
of
SECO.
SECO. And tuning in for that landing on the left-hand side. Hopefully we stick it.
Maybe. Uh-oh. Uh-oh.
Looks
Oh,
like we
no.
lost the
Oh,
feed
no.
there. We'll try to
Oh,
bring
no.
that
Insertion.
try to bring that back to you whenever we have the opportunity. But we did hear the call out that we have good orbit for the
Uh-oh.
second
Oh, blue.
stage.
Check the boss's
So
signal. Cape.
nominal orbital insertion.
Oh, boy.
Stage 1 is landed. Landing operators
Hey.
proceed
All
into
right.
11.100 on recovery 1.
All right, it did
We
land.
did hear the call out there that the first stage has landed. Unfortunately, we weren't able to bring the video of that as it was over the horizon. And there's
There
that
it is.
view.
All right. Hey.
Once again, this is the 7th flight and therefore the 7th landing of this particular booster, also marking the 69th successful recovery of a Falcon 9 first stage. The second stage vehicle has just entered its first coast phase, which will last about 18 minutes, and we'll light that MVAC engine for a second time shortly thereafter at T plus 26 minutes and 3 seconds. We're going to take a break here, and as always, if you're interested in keeping an eye on that second stage throughout its coast phase, we'll leave you with an animation. See you back here at T plus 25 minutes.
All right, there we go. We've got our second stage in orbit. First stage landed. Fortunately, we didn't get any video from the first stage. That's kind of a bummer. Cutout. It was a weird cutout. A lot of times the cutout itself is pretty normal. A lot of times the rocket coming in will shake the feed to the video transmission feed for satellite communication there. It'll shake the antenna around, and so we lose video feed of the first stage booster landing pretty commonly, but this is a little bit different because the video just completely went blue and was gone for a while. A lot of times we see it, cut out just for like a second or two, and then it comes back. But this cut out for a couple of seconds, which is a little bit unusual. But either way, it landed, which is awesome. It's good news because this booster has already been flown now 7 times. So it is it's one of their flight leaders for reusability. Previously flown on the DM2 or DM1 mission, RadarSat, Starlink 3, Starlink 6, Starlink 9, Starlink 13. So it's seen some miles on it. Now we've got a little bit of a coast phase that's going to last. This is going to last until about 26 minutes. T plus 26 minutes. So we've got a couple of minutes to hang out, chat it up a little bit. And then we'll get a quick second stage restart at 26 minutes. And then at 31 minutes is the actual deployment. So it'll be pretty quickly after that second stage restart that we'll actually see deployment. Fairing catch, I see Ben Gilmore asking about a fairing catch. Looks like they're going to attempt one fairing catch. That usually doesn't happen until about T plus 38 to 45 minutes, somewhere in that range. We might not get any sort of news today because payload deployments at 31 minutes. Usually they end the broadcast shortly after payload deployment. And so with the fairing catch being at 38 to 45 minutes, SpaceX just might not be live anymore to give us any sort of information. They never show it to us live anyways. They always show us pictures of it. I guess I shouldn't say never. One time they showed it to us like almost live. It was like a second or two late, but we kind of saw it settling into the parachutes. We saw the one that broke, or not the parachute, the net. We saw the one that kind of broke the net. That was kind of cool. But yeah, usually we don't get like the live view of like the ship trying to maneuver and get under it. I wish they would show that. That would be pretty cool. But they're gonna try to catch one. The other one's the soft land in the water, and there is a ship that's out there that'll pluck it out of the water. Let's see, maybe they should launch a drone with a second link so communication doesn't get lost. I mean, that's basically the mitigation strategies that you would have to have, is you would need to have, I mean, a drone probably not going to work, not powerful enough to send video feed to a satellite. So you'd have to have almost like a cabled connection to some secondary ship, and then feed the video from there, and that would have your internet service. I mean, maybe you could do it with a drone. Potentially, fly a drone and use the 2G signal or something like that. I mean, there are certain options, but at the end of the day, you got to remember, what is this camera for? Is it for our entertainment? Like, that's a secondary purpose. The primary purpose is for engineering reasons. The engineers want to see what happens during landing, and they don't need to see it live because there's nothing they can do about it live. So they have the cameras, they record them, and yes, it's great to see in real time or almost real time, but at the end of the day, like, if something goes wrong, the engineering teams are going to take that camera footage and look at it after the fact. So the fact that it cuts out for 2 seconds during the actual landing event, it's just not a big deal for them. They're not. Why would they spend thousands or millions of dollars to upgrade a video system that's they don't need? We need it. We want it. They don't want it. They're sitting there going, it's fine the way it is. We got what we need. Anyways, let's see. Drones don't have enough capacity to send video from the ocean, but the Voyager 1 and 2 still send info from 9,600 trillion miles and 50 plus years old of travel. Right. Well, Steven, I'm gonna actually do a 2-Minute Tuesday video on this at some point in the near future. But sending video is way different than sending data packets. Like, data packets can arrive and they can have gaps in between their arrival. They don't have to arrive quickly. I mean, remember, you're trying to send data for a video feed. If you're sending like 720 or 1080 video, like, you're sending 30 frames a second with all those pixels, all that pixel information, and it has to be constant, because if there's a gap, that's where you get that pixelization and it breaks up. I mean, that's the problem. It's not that it's not sending it, it's sending it, but there's gaps in it because the antenna starts wiggling, so they're losing packets, they're losing bits of information while the antenna starts wiggling. So that's a problem. It's not that they can't do it, it's just it becomes a hard engineering problem. And I'm going to do a 2-Minute Tuesday video on this because I can demonstrate this in real life using our weather balloon technology, because I've done live video wireless video feeds. And I can show you how that works and why it cuts out. So we'll do that in a couple weeks. I don't know. I have to be outside for that. It's getting kind of cold, so I don't know. Maybe we'll do it soon. Might wait till the spring when it's warmer, but let's see. Maybe on the live stream they could show a replay after it lands. No reason the drone ship can't transmit the video after it lands. Yeah, that's a good point, Flying Chimp. I don't know why they don't show a replay. Because they could. They could potentially do that. I mean, it all depends on like what their video setup is. Like, I don't know if they're storing that information locally on board, but yeah, potentially that would probably be the way to go, is to show us a replay of it. But we don't know if they have to recover that info or what their setup is. But can't they use Starlink for space internet? I mean, any sort of, they actually do have a Starlink dish on the drone ship. So they do use Starlink, but those dishes are going to have the same sort of problem. I mean, that violent shaking of the dish is going to have any signal is going to have a hard time having constant communication with a satellite when you're violently shaking the dish around that's trying to communicate. Why can't they show the second stage live feed online until the start of re-entry? I mean, I don't think it's that they can't. They just don't want to. At that point, the mission's over, so they don't show that information. What else do we have for some questions? And there's also, so the same is another reason here too why we don't have a live view of the second stage right now, because there are no tracking stations that are able to pick up the video feed of stage 2 right now. That's why they're showing this animation and not a live feed of stage 2. So it goes in and out of tracking stations, and that's why we don't see that. Let's see. Adam Farmer, thanks again for the super chat. He said, my kids watched. Thanks. They still don't care. Come on, kids. Come on, kids. Get into it. This is exciting stuff. I'm sorry to hear that, Adam, but I'm going to keep trying. We'll keep trying. Come on, kids. This is fun. Tushant Patil. Happy birthday, Tushant. Is it your birthday, Tushant? Apparently it's his birthday. He sent a super chat to celebrate his own birthday. Well, happy birthday, Tushant. Thanks for your support on the channel. Hope you have a great birthday. Let's go. We'll grab a couple other. Why not connect the drone ship to a support ship via a long cable for more stable video feed? Yeah, that would be the likely solution that they would need there. That's from Michael Bass. But the only support ship that they have out there is the one that has the people on board. So they send a drone ship out, the crew gets the drone ship ready, then they get off the drone ship, go on a support ship, and then they leave. They back away. They go far away in case the rocket goes. So they would have to have another support ship that would have to stay close to the drone ship. And then that would probably have to be autonomous because you can't have people on board. So you need, automated station keeping systems to keep that ship in one place. So you don't have that. Or you got to have some gigantically long cable system because they go miles away from the drone ship. So yeah, could they do it? Maybe. I mean, some people have talked about like the way to do it, have some sort of like smaller floating antenna feed that they could, float out like on a raft basically that was, a couple, 100 yards away or something like that. Maybe do that. But again, we got to think of like why the cameras are there. They're there for engineering. They are not suffering engineering wise based on their current camera feeds. The only people that are suffering are us watching, and they have no obligation to make it better for us as much as we want it. Maybe someday they will. I thought for a while it seemed like the video was improving. I thought maybe they made some upgrades, but they might. It's priorities. So you gotta prioritize what they're gonna improve. How many G-forces are we feeling? Well, nothing's under power right now, so everything's at, second stage is at 0 G. First stage is at 1 G because it landed. And there's no astronauts on board, just in case the way you worded that question made it sound like you're thinking there were astronauts. There's no astronauts today. We're launching a satellite today. SiriusXM satellite. Let's see. Michael over on Periscope. Thanks for the super hearts. Appreciate your support there, Michael. Can SpaceX reuse the second stage? Nope. They toyed with that idea for a little while. It would take a lot to reuse the second stage, a complete redesign almost for the second stage. And they had thought about doing it, but they ultimately decided not to, and they're focusing on Starship, which will be fully reusable, designed to be fully reusable from the ground up. Instead of redesigning the whole second stage, they were just like, all right, we'll leave the second stage just the way it is. We'll design this whole new platform that'll replace the Falcon 9, and we'll have a reusable second stage. So, no, second stage is not reusable. Who are you? Who are you? My name's on the screen. Who are you is the question. Who are you? Who are you? So angry. Why are you so angry? It's right here. It's on the screen. See, I don't know why that one got me. It's making me laugh. You grab a couple of other... What will happen to the second stage after the satellite's deployed? Well, there's no second stage hazard zone, which would... Normally, we would see a second stage hazard zone if they were going to burn it up in the atmosphere and bring it back. There is not one this time around. So that generally means that they're going to boost it into a disposal orbit, which is a lot of times is a like heliocentric orbit, or sometimes it's like a graveyard Earth orbit. But yeah, they will. It doesn't look like they're re-entering the second stage. They're going to boost it to a garbage disposal orbit, which we have a couple of orbits that are meant for that, or processes for that, so it's not uncommon for some of these highly elliptical geostationary transfer orbits. What time will it land? Well, you already missed the landing. There's no more landing. We're waiting on deployment here now. Any news on SN9? Yeah, SN9 tipped over. I think they tipped it back up, but it is a little bit damaged. So we're probably talking at least a delay. Don't know if they're going to be able to repair it. We'll see. It looked like minor damage, so hopefully they'll be able to repair it. Does the second stage deorbitate? Nope. Second stage is not going to deorbitate. So...
It's going to deorbitate.
No, it's not going to deorbitate. Not going to deorbitate today. Are they going to dock? No, there's no docking. This is not a crewed mission. This is a satellite mission, so they're deploying a satellite. There's no docking here. They're going to deploy the satellite, and then the mission will be over. That'll be it. That'll be the end. What happens to the parachute after the fairing landing? It's a good question. I don't think they've really ever said, but I assume that they recover the parachute. I mean, they do that with the crew capsule. They recover the parachutes. I don't know if they use those again. Maybe, but yeah, I assume that they recover the parachute, because that would still be pretty close by after the catch. When are they launching SN9? I have no idea. We gotta find out if they can even repair it first. Have they said whether for fairing recovery was successful yet, or no? Generally, they make a determination on fairing recovery weather, usually at about T plus 30 minutes, and they never tell us what it is. But usually at about 30 minutes, they make that go-no-go call for fairing recovery attempt. So we're still like 5.5 minutes away from that, so they wouldn't have made that decision yet, but they're coming up close, but they never tell us one way or another. What happens in the second stage? We're looking at a disposal orbit today for the second stage. So it's going to stay in orbit, but a disposal orbit. They'll boost it to a disposal orbit. At least that's what I assume, because we have no second stage re-entry hazard for today. Why is the speed stationary? Because we're not under power right now, so we're in a constant speed. We're not accelerating.
And so far this afternoon, we had a smooth liftoff at 12:30 p.m. Eastern. 2.5 minutes later, our first and second stages successfully separated. The first stage, which made its 7th flight today, landed on our drone ship. Just read the instructions. And the second stage completed its first burn, successfully inserting the SXM-7 and second stage into its planned parking orbit.
Gigantic space mouse.
Right now, we're coming up on the
huge.
second burn of the upper stage engine here in just a couple of minutes. Currently, the flight computer is commanding the settling thrusters to turn on and off, releasing nitrogen gas that helps lightly push the stage, allowing propellant to stay at the bottom of the tank above the engine, right where we need it. We're expecting that second engine start 2 to occur in a couple of seconds.
So we should have restart pretty much right now. There it goes. There we
And
go.
there we can see that MVAC engine has ignited.
And it's only like
And the nozzle
couple
beginning
of
to
seconds.
turn
Like 30 seconds, I
a
think.
lovely orange. At this point in time, the second stage will burn for about 45 seconds, adding over 2,000 meters per second to the second stage's speed before shutting it down for a second time. That shutdown event is called SECO 2, or Second Engine Cutoff Number 2.
So it's a quick burn. Should be shutting down shortly here. Oh, I forgot about the telemetry. It's over
This
now.
burn places
I
the
missed it.
SXM satellite into the required orbit prior to separating it from Falcon 9.
That should be it.
And we had confirmation that we have a good burn
Nominal orbit insertion.
and nominal orbit for that second stage.
Here we go.
As a reminder for those tuning in, the SXM-7 satellite is still attached to the Falcon 9 second stage. That second stage is now going to start a slow spin, which will help stabilize the SXM-7 satellite when it's released. This transition will take about 5 minutes, with satellite separation at approximately T plus 31 minutes and 38 seconds. While we'll wait for the satellite to get closer to its final destination, we'll pause commentary for now during this quick coast phase, but we'll come back in just before separation takes place in about 3 minutes. So we'll be back here at T plus 30 minutes. Stay tuned.
All right, quick break for them. They'll be back here in just a minute. They're about to deploy the satellite in just a couple minutes. I saw a couple people asking about like why the foil on the second stage doesn't tear. You got to think about like what forces would actually be applied on that would actually tear. And there's no atmosphere, so there's no air pressure or anything like that. Even though it's traveling 33,000 kilometers per hour, there's no atmosphere, so there's not really much of a force being imparted on that foil there. And even when it's under powered flight, I mean it's only hitting like 2 Gs, which you can hit 2 Gs in your car if you brake hard enough. So there's not really that much force being imparted on that foil there. A little bit of vibration that we can see, but not a ton of force. So we're coming up on satellite deployment. Let's see. Did I miss any other questions? Will SpaceX ever make the second stage reusable? No, not on the Falcon 9. They've decided not to do that. You can see some of the flashes there. That's thruster activity. Maybe we'll see them from this view. I don't know if we'll see it from that view, but we can see it here. You can see some of the flashes from the thruster activity as it's orienting the the second stage for the deployment attitude. Why does SpaceX reuse the fairing? Because it's cheaper. They save money. Do we know what the satellite is for? It's a SiriusXM satellite for satellite radio. It's going to replace one of their existing SiriusXM satellites. The real YT says, per Tasmanian, the old satellite, XM3, will go into disposal orbit. Yeah, that sounds about right. Usually that's what geostationary satellites,
SXM-7 mission
too much energy required to bring them back to burn up in the atmosphere.
On-time launch at 12:30 p.m. Eastern Time, followed by a successful ascent, stage separation, first stage landing, and 2 second stage engine burns. We have just one more major milestone coming up today, which of course is the deployment of the SXM-7 satellite from the Falcon 9 second stage, which you see there on your screen now. That separation is scheduled to take place about a minute from now.
That's normal venting, liquid
The satellite
oxygen
that we're
venting.
carrying on board today, the SXM-7, is SiriusXM's next generation high-power broadcasting satellite.
Acquisition of signal HPK.
It was designed to provide service for more than 15 years, and it'll be joining SiriusXM's active fleet to provide audio entertainment and data services to the continental United States, Canada, Puerto Rico, and the Caribbean. It'll be outputting over 8,000 watts of content, meaning it will deliver the highest power density of any commercial satellite on orbit. And it's intended to replace the SXM-3 satellite that is currently on orbit. About 20 seconds away from that payload deployment. There on your screen, we have a great shot of the SXM-7 satellite.
I saw somebody said that the fairings cost $1,000. They're way more expensive than that. They're like $6 million for the payload fairings. That's why they reuse them. $1,000. No. Like $6 million.
Payload separation confirmed.
And there
There it
on your
is.
screen, we can see that
Whoa.
the payload has separated. We've received confirmation of that successful separation of the SXM-7 satellite from our second stage, which will be bringing our webcast today to a close. Thank you to SiriusXM for entrusting us with the SXM-7 satellite. This mission marked the 7th launch and landing for this particular Falcon 9 booster, SpaceX's 69th successful booster landing, and despite a crazy 2020, our 25th launch this year. To the range and FAA, we appreciate having your support for today's mission. And to all of our viewers, as always, thank you for joining us and have a great day.
Bye, Kate. Thanks for the webcast today, Kate. Oh, she's still on. They started the music. There we go. Oh, that would be the worst when you just have to stand there awkwardly, wait until they cut the camera feed. You're like, come on, guys, cut it. Oh, all right. Yeah, there we can see our SXM satellite floating away, deployed off the front of the Falcon 9. And that will still has some a way to go to get it into its final orbit, but that will float away and then over the next couple weeks get itself into its final orbit there. There we go. I was just waiting for them to wrap it up. And we'll probably take a look at a quick replay. A couple of things that I wanted to show. We saw a gigantic space mouse today. I'll explain what the space mouse is in a minute for anybody that's new that doesn't know what we're talking about. Talk about that in a minute. Do you think you'd ever do a 2-Minute Tuesday on aerospikes? Sure, maybe. I don't have one planned, but let me know in our Discord if you have ideas for that. You can join our Discord. It's free if you'd like to hang out and chat with us. I'm sure one of our awesome moderators will put a link to our Discord in the channel if it's something that you want to do and you want to join our Discord and chat it up with a whole bunch of like-minded space fans. And then I guess I'll take this opportunity also to give you my sales pitch, which is always that if you want to take the extra step and consider supporting the channel directly in a more direct manner, you can become a Patreon member or a YouTube channel member. That helps support the channel. And everything goes right back into it because Overlook Horizon is a nonprofit 501c3 here in the US. And so none of it comes to me personally. All goes back into the channel. There's my sales pitch. But even if you don't want to do any of that kind of stuff, consider joining the Discord because that's free. There's no cost for that. You just join our community and chat with us. All right, we'll set this up for a replay here, and I've got it almost up and ready to go. Just want to drop a couple links here in Facebook and the Twitch machine. A couple people asked if I was an astronaut. I'm not an astronaut. But We'll go through a couple of others. I guess we'll switch to this view here, and we should probably put up our replay text so people know it's a replay. I was bummed again about the pad microphones. They used to be so awesome. But the last couple launches, they've been dropping them down. It was okay this time around, but pad microphones were not amazing this time around. That was kind of a bummer. Let's see, what else did I miss for questions here while we wait for the replay?
So there we heard the
Are you a software developer? Yes, I'm a software engineer. I don't want Discord. All right, don't get Discord then. Fine, that's fine.
First and second stages are beginning to pressurize.
Is this geostationary orbits? Yeah, well, it's supposed to be geostationary orbits. They mentioned something about medium Earth orbits, but I missed what they had said. But we were expecting before launch that this was going to be a geostationary Earth orbiting satellite. The Falcon 9 almost never goes directly to geostationary Earth orbit. Usually it puts it in a transfer orbit, and then the spacecraft itself will circularize and use its own onboard systems to get it into its final orbit.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition, and we have liftoff.
Stage 1 propulsion nominal.
Vehicle's pitching downrange.
We're now 30 seconds into flight, and Falcon 9 is preparing to pass through max Q, which will happen at T plus 1 minute and 12 seconds. For those of you that might be unfamiliar with this term, max Q is when the vehicle will experience the greatest amount of dynamic pressure. Call out there that everything is looking nominal for first stage. To prepare for max Q, we throttle the engines down and then back up about 20 seconds later. And this helps ensure that we keep those dynamic pressures below a certain level.
Falcon 9 is supersonic.
So there we heard the call out that the vehicle is now going faster than the speed of sound.
So I'll turn this down.
Is experiencing maximum dynamic pressure.
Turn this down a little bit while we talk over it, since it is a replay here, because I saw a couple other questions. Somebody asked, why do the engineers need cameras? That would be if there's any sort of anomaly. They use camera footage quite a bit to try to detect and analyze any sort of anomaly. That's actually why we have these tracking cameras. Like, they're tracking the vehicle not for entertainment purposes. They're tracking them for engineering purposes. They're like, well, we have these cameras anyways. We might as well show it to people. But yeah, these camera views, all these tracking views are generally intended for engineering purposes. So if they have an engine out, they can go back and play it frame by frame in super slow motion and figure out exactly what happened. If there's a vehicle anomaly, they can figure out what happened. I mean, that's how a lot of the Challenger disaster was discovered. They went back and analyzed a bunch of the video footage, and they were looking at, the puff of smoke that came out of the SRB right at launch, and then they saw the breach in the SRB a few seconds before vehicle breakup and things like that. So a lot of these that's kind of what the cameras are. The primary purpose of the cameras is. Stage 2 should dock to the ISS. Maybe some materials can be reused. It's not even in the same orbit as the ISS. So he would need so much energy to try to dock to the ISS, because it's not even in the same, not even in remotely the same orbit. So the amount of energy that you would need. The amount of energy that you would need just to try to get it to the ISS would be huge.
Rotating behind the first stage, which is on the left-hand side of your screen, and the second stage on the right-hand side. So on the left-hand side, we can see those grid fins beginning to deploy into the landing position. Those grid fins will be utilized to help steer Falcon 9 for a precise landing on our drone ship, which, like I mentioned earlier, is positioned a couple hundred
Vehicles on a
miles.
nominal trajectory.
Nominal trajectory there for.
Robert
Falcon
wants to
9.
know, was
As I
that
said,
the
those,
sonic boom we heard a few seconds and the announcement of reaching supersonic speed? So sonic booms generally propagate in the direction of travel, which is why we usually don't hear sonic booms from launch. Like, there would be a sonic boom generated, but sonic booms generally propagate in the direction of travel. So I would doubt that we heard, I didn't listen, I'd have to listen back and hear what we heard, but usually we wouldn't hear a sonic boom during launch because they would propagate out away from all the launch facilities. And then when it lands, if it does an RTLS landing, it's coming back towards, it's traveling back towards the launch facility, so those propagate out that direction.
The first of 2 planned MVAC burns. At stage separation, the first stage's velocity.
What are the
is
4
about
towers around the rocket on the launch pad? Those are lightning,
5,000
basically giant lightning rods. So Florida is like the lightning capital of the world. So those are all lightning protection towers that are basically just gigantic lightning rods so that lightning would strike the towers and not the rocket.
As it coasts for a couple of minutes prior to starting its downward return back to Earth.
Acquisition signal Bermuda.
I would imagine that showing these videos to the public helps with stocks, etc. Maybe the public being involved, interested in space, will help speed up advancements. I would say yes and no to that, Cody. Cody's one of our YouTube channel members. Thanks for your support, Cody. SpaceX is a private company, so there's no stocks. But so that's the no part. But the yes part is, like, yes, getting the public interested in spaceflight is a benefit to SpaceX and all the space companies. The more people are interested in spaceflight and see how this is useful and see how, all this technology can benefit humanity, the more that directs, public space policy and funding and things like that. So the public's interest in space directly plays a role in, the success of SpaceX. So that's the yes part of the question. That you're definitely right about that. All right. I thought SpaceX always deorbited the second stage. It's gonna deorbit. Where was that question? Into a disposal zone in the Pacific Ocean. I would say not always. Always is the wrong term there. Usually, yes, not always. Most of the time, in order to deorbit, it's gonna deorbit. They would have to, they need some fuel that's left over, and a lot of times that's gonna be your low Earth orbit satellites that'll deorbit. So they'll do that on the low Earth orbit. But this is a geostationary transfer orbit, so it's this really long elliptical orbit that they just put this in. Do you mean geostationary orbit? No, usually, so low Earth orbit is usually where we would see the second stage come back. Falcon 9 rarely goes directly to geostationary orbit. A lot of times they would do a geostationary transfer orbit, which is like an elliptical, elongated oval that one end is in low Earth orbit, the other end is in geostationary orbit. So they do this long elliptical orbits, that's geostationary transfer orbits. And with that, you need to expend more energy to elongate that oval, so there's not a lot of fuel left to deorbit. It's gonna deorbit. So, could they do it? Sometimes, but it's a little more rare in these GTO orbits. Can't they change something on stage 2 to be reused somehow? It's sad when it's just floating around. Yeah, that's your rocket paradox there. So in order to make it reusable, you got to add more equipment. In order to add more equipment, you're going to need more fuel to lift the rocket. If you add more fuel to lift the rocket, it's heavier, and now you need more fuel to lift that fuel. And now you just added more fuel, so you need more fuel to lift that fuel, and now you need more fuel to lift that fuel, and to lift that fuel, and that fuel, and that fuel, and that, and so you get yourself into a paradox there, where eventually you have to sacrifice something. Like you either sacrifice your payload, your deployment orbit, because you don't have enough energy to get to your deployment orbit, or you got to sacrifice your payload weight. You won't be able to lift as heavy of a payload, or you sacrifice not recovering the second stage, which is what since that part. The other parts generally are what get them customers. Being able to lift a heavy payload and get it to the right orbits. That's what gets them customers and gets them paid. Recovering the second stage would be a competitive advantage, but it's not any. Their existing system isn't any worse than their competition, so that's what got sacrificed.
Hopefully we stick it. Looks like we lost the feed there. We'll try to bring that.
Let's.
We have the opportunity, but we did hear the call out that we have good orbit for the second stage. So nominal orbital insertion.
We should. I'm gonna. You know what? I'm gonna start. I didn't have plans for this, but I'm gonna pull up Kerbal because a lot of people are asking about geostationary transfer orbit. So I'm gonna pull up Kerbal and I'll show you what that geostationary transfer orbit looks like. It'll take a couple minutes to get that started.
Unfortunately, we weren't able to bring the video of that as it was over the horizon. And there's that view. Once again, this is the 7th flight and therefore the 7th landing of this particular booster, also marking the 69th successful recovery of a Falcon 9 first stage. The second stage vehicle has just entered its first coast phase, which will last about 18 minutes, and will light that MVAC engine for a second time shortly thereafter at T plus 26 minutes and 3 seconds. We're going to take a break here, and as always, if you're interested in keeping an eye on that second stage throughout its coast phase, we'll leave you with an animation.
You know what? You know what we got to look at? There is a huge space mouse. We forgot about that. Let's pull it up. Where was it? It was like 25 minutes that I saw it. And then I'll explain what the space mouse is for everybody that's not in the know, hasn't been around the channel, doesn't know what we're talking about, or why this crazy guy in the corner is talking about mice during a rocket launch. Let me show you what we're talking about here. Let's see, fast forward. It was right when they showed the rocket. Is that it? Yep, there it is, right there. Oh, they cut away from it. So, what I'm talking about is right here. You're going to see this little piece here break off the rocket. It's actually quite a large piece. Breaks off the rocket. You can actually see another one right here. All of this right here that looks like it's leaking out of the rocket there, that is the liquid oxygen vent port on the second stage. So it's venting liquid oxygen to keep its pressure nominal so it doesn't overpressurize the vehicle there. And it can actually suffer from, as that liquid oxygen vents out, you can get vacuum-induced solidification there, basically. So this is solidified oxygen that's just clumped together, and it's just stuck to the vehicle next to the vent port there. It's just attached to it, and then eventually it breaks off and just kind of floats away. You can actually see a little bit of it right here on the vent port as well. That would probably break away if they left this camera angle long enough, but that's it. And the reason we call it a space mouse, like back on the Demo 2 mission, occasionally that will break off and it'll actually get stuck in the plumbing here. So it'll break off, you can see it right there, and sometimes it gets stuck on the plumbing and it'll kind of run along the plumbing here as the vehicle vibrates. And on the Demo 2 mission, a bunch of conspiracy theorists that thought that there was a mouse that was on the second stage. See, it's fake. There's a mouse there. Okay, one, this engine bell is huge. It's enormous. Like, that would be a mouse the size of a small cat. It'd be the biggest mouse you've ever seen in your life. So it'd be a huge mouse. And two, it has a perfectly normal explanation. It's solidified oxygen. So that's what we call the space mouse around here. So when you see that, tell people you saw the space mouse. All right, is this live footage? Well, you're looking at a replay here now. The rocket's already launched. We're playing a replay right now because it was you missed the launch if you're just joining us now. All right, let me see. Did my Kerbal come up so we can show some geostation? Oh, it's almost up. We're almost there. And then I'll show you, we'll launch our own Falcon 9, and I'll show you geostationary transfer orbit. Gary says, put your helmets on. Tori's going to open his Kerbal. Gary, I suspect that you are disparaging my Kerbal piloting skills. Is this a correct assumption, Gary? Are you doubting me? I don't know what would have given you that perception. Surely a tweak at apogee of GTO would send the GTO perigee into the Earth. When that perigee is aligned for the Pacific, I can't believe they leave these second stages forever to fly dangerously into low Earth orbit. Yeah, so I mean that would be the method to deorbit it, and sometimes they can.
It's gonna deorbit.
Right, sometimes they can do that, but it doesn't appear that they're doing that for this launch because they didn't publish a second stage re-entry hazard zone. Let's see, Virginia wants to know, have you practiced your Kerbal game? I don't practice, Virginia. Where's the fun in that? I'm not gonna practice. It's more fun to do it live with you guys, and then you can see what happens. That's way more fun, I think. Let's see. Kerbal Space Program costs $40 US. I'd rather buy a Raspberry Pi 4. I think that's about right. I think it does cost somewhere around $40. Not 100% sure though. I purchased Kerbal Space Program like probably 8 years ago. I got it when it was still a very, very early version game. It's way different than it is now, but let's see. All right, so what I'm going to do now, I want to we're going to try to launch our Falcon 9 here in Kerbal. Right there. We got our Falcon 9 rocket. Looks like it's reused. It's a reused Falcon 9. And we should probably throw some sort of payload in here with it. Let's just pick one of the stock satellites or something. What do we have for stock satellites? Space Station Core communication satellite. There it is. Let's merge in the communication satellite. Put that in there. The question is, will it fit? And then we'll launch this to geostationary. Let's see, retract. Let's move this out of the way. And we'll put this. Maybe this is always the hardest part. Trying to attach that to that somehow. How are we gonna do that? I never know how to do this. Like just attach. What do I have to? I have to hold. What is it? Control or Alt? No, it doesn't want to attach. Attach. Somebody teach me. Teach me how to do it. We want to launch this satellite, and I want to attach it. Control, Shift. What's the hotkey to just tell it to attach? Somebody tell me in the chat. And then we'll show you geostationary transfer orbit. Should have practiced. I don't practice. Practice is for people that don't want to blow up rockets. I have it here. So you got Alt F4. You need a subassembly. The subassembly has only one attachment point that you can use. Make sure it actually has one at the bottom. Set the bottommost part on the satellite as the root, then attach it to the Falcon. This sounds really complicated, you guys. What do you mean a subassembly? I'll just add my own satellite on there. We can do that too. Control A. That doesn't do it. That flips it around. Who's telling me Control A? That doesn't seem right. All right, well, I just reroute the bottom until it works. Well, I guess we're gonna get rid of this. Go away. We'll just make our own satellite. It doesn't really have to be anything crazy. We'll just put, is this a... What is this? A fairing adapter. Will that separate if I... There is no... That's our payload fairing, so I probably need some sort of coupling there, yeah? Nope, not like that. Some sort of nope, it's a docking port. Decoupling is actually that's what I'm looking for. That's kind of big. There, that one fits. We'll do that. We'll put that on there. There, we'll just launch that. Right? That's fine. Let's see, we need to move this up here. This down here. Check your staging. Gotta check.
That is improper staging.
Yeah, we don't want improper staging today. We need to check our staging. Then we need to put our fairing back on, which does not want to go back on. There. All right. Yeah, we did it. Oh, wait. Let's check our staging again, because our fairings... Need another stage for the fairing. Nope, not that one. This one. All right, let's put this in geostationary transfer orbit. All right, I think we finally did it. Let's go. Send it. Here we go. We're sending this guy to geostationary transfer orbit, so you guys can get an idea for the few people that asked what I'm talking about. And if we're gonna launch a Falcon 9, uh-oh, I might have just started a second instance of Kerbal. I did. Oops. Well, hopefully that doesn't crush my processor. Get that closed. There we go. You could stick a space lobster and send it to geostationary Earth. I think, Gregorius, did you make that space lobster for me? I don't have it anymore. I gotta find it. I probably still have the file, but it's not installed right now. All right, let me put myself here. And now if we're gonna launch, we need some appropriate launch music. All right, there's our launch tune. So far we're on a nominal trajectory. Let's see if we can keep it up. Uh-oh, we're getting some atmospheric heating. We better throttle down a touch. We're getting some heating. We don't want that. We went a little fast. We're still at 30. We're barely at 40 kilometers. There we go. Throttle up. even gonna actually pitch down just a bit because our apogee's getting a little high. So this will be counterintuitive. Seems kind of weird, but trust me, it works. We already got enough speed to hit a 93 kilometer. We're still going up. Here we go. Separation. Ignition. $95-kilometer apogee. We're even gonna pitch down a little bit more. Seems counterintuitive, but just trust me on it, all right? All right, I got you. Your pale Tory's got you here. Don't worry. Don't worry, I'm a professional. A lot of people that have watched me play Kerbal before, they're going, yeah, no. Fairing separation. Goodbye. There they go. I'm gonna pitch down a little bit more again. Again, it seems weird. Seems really weird. There we go. There's our cutoff. Now we're going into a coast phase. We're good. All right, so right now, this is not the orbit that we're wanting to be in. But we're waiting on our coast phase now. Okay, just like SpaceX, just like the professionals do it. Come on, I got this, guys. I got this. All right, here we go. So we're in a almost circular orbit. So our apogee, let's see, which vehicle is ours? This is our vehicle right there. It's gonna follow this green path. And it's gonna hit this apogee that's out here. Let's see, let's focus on Kerbin, aka the Earth. It's gonna hit apogee at 110 kilometers up here. It's almost circular. We got a perigee that's 32 kilometers, so it's not quite circular. 32 kilometers, that's gonna cause us to re-enter. Then you can see on the second orbit, actually, it would end up deorbiting. It's gonna deorbitate. Right, exactly. So that's not good. So we need to do our coast phase. We're gonna coast to apogee. We'll warp. We're gonna. Nice thing about Kerbal is we can fast forward. We're gonna fast forward to our apogee, and we're gonna do a prograde burn. I don't know what geostationary orbit is in Kerbal. This is a different planet size, so. But here we go. So now we're doing our burn. Now we watch. Here goes so we're down here. Our vehicle's down in this direction. But our apogee is extending on the other side, so this is where we're starting our geostationary transfer orbit. There's the moon out there. I don't know what the actual apogee is for geostationary here in Kerbal world. But we'll pretend it's like there. Something like that, right? Just take a quick guess. So here, when we talk about geostationary transfer orbit, it looks something like this. So this is where the Falcon 9 would then no longer be under powered flight. We'd probably fast forward just a little bit. They'd check out the vehicle, make sure it's good to go. Sometimes with the vehicle, they'll even do something like this, where they'll spin it. I don't know if they were on this particular flight, but sometimes they'll spin it like this. Use the thrusters to spin and spin and spin. We'll do it today. Why not? Let's get a big spin up. And basically it stabilizes the satellite. So we'll get a big spin going here on that second stage. Like this. Here we go. Bring it up. Spin it up. Come on. Spin that. Look. Oh my goodness. Look how fast it's spinning. Holy smokes. All right. Ready? Ready. Here we go. And somebody asked in the stream, why was the speed slowing down? So when you're not in a circular orbit anymore, as you start to go towards your apogee, your speed slows down because basically Earth is pulling you back in. So your perigee is the fastest point. And oh boy, now we're getting a wobble. All right, we better deploy it. Ready? Go. There she goes. She's off. Oh, interesting. Interesting that it's heading that way. Oh, there she goes. Very interesting. That was good. But there goes our satellite, which will now be in geostationary transfer orbit, and SiriusXM would have to use their onboard propulsion systems to circularize that later on. But there it goes. The way it goes. But anyways, yeah, so the speed will slow down. So as you go out to here to apogee, your slowest point in your orbit is out here. And then you start to speed up as you get pulled closer into the Earth. It pulls you faster and faster and faster, and then you hit the perigee and you go, woo! And then you start slowing down as you go back to apogee again. So there we go. Hey, that worked pretty good. All you people that are doubting my Kerbal skills. I got this. I got it. Let's see, where can we see our separate craft there? Fairing. Well, there it is. So there. That is our satellite that's in orbit now. All right. Well, one small step for man, one giant leap for Tori. We did it. We got it. We didn't blow anything up today. Now, usually, we'll even show, let's show this. This is not what happens in real life, but we'll show it anyways. If they were going to deorbit...
It's going to deorbitate.
If they were going to deorbit the second stage, the way to do that the most efficiently would be to wait until you get up here. So we'd have to fast forward with the second stage. There's our Earth. We'd have to fast forward, wait till we get up here to our peak, our apogee, our furthest point away from... Oh, now I don't have any control over it. Okay, well, that's because we don't have any communication with the home station here, so... Well, at this point, you would do another burn. I can't, because we lost communication with our vehicle. So, just like we were talking about with the video feeds, things that in this instance, I have no communication with it. I can't command it. I can't tell it what to do because it's out of communication range. So, I can't even stop the spin. So, it's just going to do its own thing. Okay, well, I was going to show you how to deorbit.
It's going to deorbitate.
But I guess we're not going to show that. Just warp it. It'll come back to Earth. Yeah, we could warp and see if we get signal back. Would come back here. We'd come back. Come back. We're still not gonna. We're gonna have to be directly over the Space Center to actually get. I wonder, is this our? No. Okay. Well, still have no control. Can we get it back? We can't get it back. I was gonna try to blow something up for you. But I'm sorry. I cannot blow something up today. Bummer. Have no... Well, maybe we'll get control over it on the second orbit. This will be directly over the Space Center. Isn't that it? Oh no, that's Desert Launch Site. Where's our Space Center? Let's try it. Oh, wait. Whoa, oh, wait a minute. Still don't have control. I can't catch the Space Center. Whoa. All right, well, we're going to do a whole bunch of orbits. Notice how as you get closer... Here you go. Here's a good demonstration. As you get... Let me focus on here so it's not so crazy looking. As the vehicle gets close to Earth, it goes faster. Wow. Kind of cool, right? That's the difference in speed between your apogee and your perigee right there. Your control module went away with your satellite? Oh, maybe that's what it is. Alrighty. Well, I guess then we're just going to have to wrap up for the day. All right, well, that was fun, right? We got a successful rocket launch today. Launched a satellite, the SiriusXM-7 satellite that will replace SiriusXM-3 and give you that nice satellite radio. This is not sponsored. If I would have thought about this ahead of time, I'd have reached out to them and said, you should sponsor this, but it is not sponsored. But they did sponsor the launch, so launched that up today, successful. We don't have any news about the fairing catch, which would already have happened quite a while ago. Did they put anything out on Twitter? Let me just check real quick and see if they put anything out on Twitter. I'm sure one of my moderators probably saw it or could tell me faster, but yeah, I don't see anything out there. Deployment, first stage landing. Yeah, I don't see anything. No news about the fairing, which is not entirely unusual. We might find out about that later. But in the meantime, I'm going to head out. Consider joining our Discord. We can continue the conversation there. There's no cost to do that. It's free. You have fun with us. You chat it up. You learn about space. You ask questions. We got a ton of community members there that love chatting about space. So consider joining the Discord server if you like to chat about space in between missions. I'm there. I chat it up. Other people chat it up. We have fun. We have fun times over in the Discord, and there's no cost to it. If you want to take the extra mile and consider more direct support, consider becoming a Patreon member or a YouTube channel member. It all helps the show out, helps me put on better shows, things like that. It also gets you some exclusive access to behind the scenes. And when we get sneak peeks at our 2 Minute Tuesday videos and do some exclusive live streams and things like that. So if you want to consider more direct support, you can get some benefits there by becoming a Patreon or YouTube member. But if you don't want to do any of that, that's cool too. Just like that you're here and that you're chatting with us and contributing or just watching. That's cool too. Everybody involved. All right, that's going to do it for me, everybody. Thanks for hanging out and joining us today. I'll head over to Discord if anybody's got any additional questions. And then I will see you next time on our next video. All right, thanks everybody. Have a good rest of the day. Goodbye.